You are welcome to today's lecture continuation for physics in preparation for Jamb UTME 2026. If you are a last minute candidate, if you know you have not been preparing, please don't lose hope. I've been helping last minute Jamb candidates to pass their Jamb. Then they pass, they know they believe waiting they see. If Jamb results come out, that's also dash, then they dash me things. I know why I tell you. My bed today for house, my phone for house, my mattress is 18 inches. Now person give me that phone. This last Jamb 2025, now person give me that phone. The person just dash me phone. Deliver phone for me. He carry phone give me from Lagos, mattress. I was so shocked. I know they talk about the goats where they give me. I received 2 goats last year. 2 goats. I don't believe my eye when they come. Plus all the gifts, both cash, airtime, where they give me when results come out. I can make a difference in your life. All you need to do, this exam, it can still count. Even though you have not been preparing. Your preparation can still count. Even though say now 3 weeks remain, I have a plan that will work for you. So all you have to do, just send me a DM and I will help you. Okay? How do you get my phone number? Just go to my profile. Just go straight to my channel. Okay? The profile of my channel, you are going to see my phone number below my channel description there. Underneath, you will see my phone number there. Send me a message and I will help you. If it's this lesson notes you want, this is my short, concise lesson notes straight to the point that covers all the syllabus of Jamb UTME, leaving no stones unturned, come to my DM. I will surely send this to you, okay, for a very little token. Remember, I have it available in physics, chemistry, biology, and English. Now, let's continue with our topic for today. Our topic for today is electrostatics. Electrostatics, all right? So, get your pen and your notebook to jot down whatever you understand in this lecture because you are definitely going to need it for subsequent revision. Those who have ear, let them what? Electrostatics. What's electrostatics? This electrostatic comprises of 2 words, electro and static. Okay? Electro means electric current. Electric current. Okay? And static means something that is not moving. It's static. It is one place, like stagnant water. It is one place, like your bed for house. It not they move. It is static. You'll be like, as I did here, I know they move. I am static. So, what the concept is all about is, the entire concept, what it's all about is that electric current is induced from a static object. Electric current is formed from a static object. Object will not they move. Okay? The study of stationary charges. The charge is formed from stationary objects. From objects will not they move. That is electrostatics. Because you have these statics, that's why it's now a study. Statics. Statistics. That's a study. But when you say static, is the generation of electricity from a static what? Object. An object that is not moving. Stationary object. Okay? That's what? Electrostatic. And there are 2 types of charges. Okay? You have the positive charge, which can also be called protons. Okay? Can call it protons. And you have the negative charge, which are also called what? Electrons. Alright? And matter contains both. Matter contains both this positive charge and negative charge. Remember, electron is found orbiting around the shell of atoms at different energy level. Okay? Quantized energy level. Okay? According to who? Who made that postulation? You don't know him. You don't know him. Better go and take my lecture. It's very short, straight to the point. As the ticker, they enter your head. Okay? Atomic theory. Alright? So, matter contains both of them. Remember, an atom, an atom comprises of nucleus and the shell. Okay? The nucleus comprises of what? Protons and neutrons. Okay? That's what makes up the nucleus. While the shell, the outside, consists of what? You have electrons there and it's negatively charged. So, let's look at charging. Alright? What is charging? Charging is inducing charge. Okay? Into a body. You are inducing charge into a body that is not charged. To charge a body, so that body will possess a positive charge, what do you have to do? Just carry cotton. You know cotton, like cotton wool or cotton cloth material. The rubber for silk. Rubbing cotton on silk forms what? Positive what? Charge. That is how you form positive charge. Rubbing cotton on silk. Jamb, they said well. Positive charge is formed by what? Rubbing cotton on silk. So when you rub this cotton on a silk rod, okay, a silk rod, for example, when you rub it on the silk rod for some time, maybe like 30 seconds, if you carry that silk rod and take it close to a negatively charged body, like paper for example, okay, it's going to attract that paper. You understand? Because it has been charged. Unlike charge attracts, like charge repel. So, how do you form negative charge? How do you charge an object to be negatively charged? Or how do you make an object to be negatively charged? You do that by rubbing 4 on ebonite rod. Rubbing 4 on ebonite rod, just like the same way you did for positive charge. Do it like this for 30 seconds. If you do it, take it close to a positive charge, it's going to attract. Unlike charge attracts, like charge repel. Unlike charge attracts, like charge repel. So for example, we did this one in primary school those days, okay? Pick your pen, that place where you take the right for your pen, carry and rub it for your hair. Your hair is fury now. This your hair is 4, okay? It's fury. You are a fury animal, okay? As a mama, you are a fury animal. So rub it for your head. Rub am for your head, rub am for your head, rub am for your head for 30 seconds. Start your pen, that place where you take the right. Like this, will not be like say you dey write for your head. Nobody write for your head, decide, just the rub am for 30 seconds. Then, immediately as you rub am finish, just tear small piece of paper. Bring that your pen, the head of your pen, close to it. You are going to notice that it's going to attract because you have charged the tip of that pen to be negatively charged, and that paper, that small paper where you tear put for table, where it attracts is positive charge. So unlike charge attract, like charge repel. All right. You can also bring about charging by induction. All right, which is no contact, just through ground. All right, no contact, just through what? Grounding. Okay, that's how you induce a body. You induce electricity to a body. So just know that this style of charging a body, which is rubbing cotton on silk rod or rubbing for on ebonite rod, all these are the ones involving contact. But induction does not involve contact. You can either charge it through what? Earthing, which is grounding, okay? Earth to connect and go ground, or through this contact form, okay? Like rubbing cotton on silk rod or rubbing for on ebonite rod. But when you are charging through induction, contact is not required, okay? Just grounding. So grounding or earthing is also part of charging through induction. That's what this means, okay? So you either charge through contact or without contact. If you are charging through contact, you use all this type. But if you are charging without contact, use induction, okay? Use induction without contact. An electroscope, look at it here, is a device used to detect charge, okay? We have a gold leaf electroscope. That's the most common one, and that's the one set by Jamb. Gold leaf electroscope. I already made a video. I have a lecture on gold leaf electroscope and the particular question that Jamb sets from gold leaf electroscope, all right? So I'm only going to give you an overview of gold leaf electroscope. So you go take that lecture. It's there in the physics series, okay? Jamb must repeat physics question. Open that series or the playlist of this video that you are watching currently. Look at the playlist. You are going to see it there. All right. A gold leaf electroscope is used to detect the presence or the passage of electric charge. It does not only detect the passage of electric charge, it also detects the nature of the charge. Is this charge a positive charge or a negative charge? So it tells us if it is a positive charge or it's a negative charge. That's what the gold leaf electroscope does. One unique thing that it does. All right. The divergence of the leaf, when the leaf diverges, it shows that there are more than one charge in the system. That's you have introduced a new charge that was not in the system. So that tells you that if the gold leaf electroscope was positively charged and immediately you bring it in contact with a body and the leaf diverges like this, that shows you that what you brought is a positive charge, because like charge repair, it makes the leaf to what? To repair. Okay, it repairs. But if it was a positive charge that you introduce when the gold leaf electroscope has already been positively charged, and you bring it in contact with a positively charged body, it is going to what? It's going to converge. All right? It's going to converge. If the leaf collapses, the gold leaf, that leaf, if the leaf collapses completely, complete collapse means that there is no charge in the system at all when it's collapsed completely. All right? So which other thing again? If the leaf collapsed slightly, it shows that you have earthed it, okay? You have grounded the gold leaf electroscope, meaning that much of the charge in the electroscope has entered the ground. So current don't reduce. That make the leaf collapse small. But if the leaf get total collapse, no current in the system, no current in the gold leaf electroscope. So go and take the lecture to understand gold leaf electroscope and how Jamb set questions on it more and more. Now, this is the illustration of, charging a body through contacts, okay? Charging a body through contacts, the one for positive charge and the one for negative charge. For positive charge, you rub silk on glass rod, okay? You rub silk on what? Glass rod, okay? Look at it. See the silk here, that the rubber for glass rod. Positive charge forms on the what? Glass rod, okay? It's charged positively. To create a negative charge through contact, you rub 4 on ebonite rod. This one here, under here is ebonite rod. And you take 4, you rub 4 on it, and a negative charge is what form. This body is charged negatively through contact. Electric field intensity, capital letter E. What is electric field intensity? Electric field intensity, the definition is very simple. Electric field intensity is the force per unit positive, this is positive charge at a point. Make sure say everything within this definition, they inside your definition, where they define electric field intensity. Is the force per unit positive charge at that point or at a point. It is the force per unit positive charge at that point or at a point. If you come out anything for inside, you go fail am. I made it very short. All right. So what is the formula? The formula is given through the definition. E, which is electric field intensity, capital letter E, is equal to force over the quantity of charge. Force over quantity of charge. This formula here is very sweet. You can use it to get other things. All you have to do is to make subject of formula. Easy, shikina, easy peasy. Do your subject of formula to get your answer. All right. If you are told, for example, now you are given electric field intensity, you are given force, and you are told to find the quantity of charge. What do? You make the quantity of charge the subject of the formula. Okay, and you get your answer. Just to bring quantity of charge here, it will now be E times F. Chikina. If you are given quantity of charge, you are given electric field intensity, you are told to look for force. All you have to do is to make force the subject of the formula. And what are you going to get? You are going to get F is equal to E times Q. Very easy. Shikina. So Jamb is overrated, and invest in calculation. It's easy. Invest in calculation. If you get one, you will say, I don't blast this one. If you get two, you will say, I don't blast this one. Once you just solve, you get your answer, you get your marks straight up. It's not like non-calculation question where you go analyze. Analysis go one kill you, your head go one blow. Now let's look at electric potential V. Jamb said we should be accustomed to all this before we enter that Jamb examination hall on April 16th. Electric potential, which is V, capital letter V, is equal to K times quantity of charge. This K here is constant. Quantity of charge, which is Coulomb, over R. Quantity of charge, which is what? Coulomb over R. What is the definition of electric potential? Potential, anywhere where you just see potential for physics, just know say now work done. Potential is work done from here to here. How this thing they move from here to here. How this thing they achieve delivery from here to here. Work done. Anywhere you see potential. Potential difference, so now still work done. So electric potential is the what? Work done in bringing a charge from infinity. From infinity to a point in an electric field. Bringing a charge from where? From infinity to a point in an what? Electric field. That's electric potential. And this is the formula. Electric potential V is equal to the constant Coulomb, which is quantity of charge, over R. R is what? Resistance. Now, potential difference, which is also V. Potential difference is the work done in moving unit positive charge from one point to another. So potential difference is easier. The work done in moving one unit positive charge from one point to another. Maybe not this point. Maybe the first point. This second point. This one at the second point. So the work done in bringing or in moving one unit positive charge from here to here, from point A to point B. That's potential difference. All right. But electric potential is from infinity to a point in the electric what? Field. As simple as that, chicken. Huh? Electric discharge slash lightning. Electric what? Discharge slash lightning. So during electric discharge, spark. So spark as a result of electric current neutralizes charge. Because of as a result of spark, charge is neutralized. That's why your battery, okay, your battery for house, if you go connect the two terminals together, you go get spark. And once the more you induce that spark through that bridging of the two terminals, the more you neutralize the charges in the battery. Before you know, the battery will die. No charge again for the battery. So that's electric discharge. Okay, you are making it to discharge all the charge. So spark neutralizes charges. So when you create spark, charges are neutralized. Okay, so electric discharge is loss of charge. That's electric discharge. Okay, it's loss of charge. So creating spark is one of the ways that you can lose charges from an electric system. Okay, so that's that for that. In electric lightning conductors divert to ground. Okay, during this electric lightning conductors divert to ground. All those things where they do earth. Earth is a kind of lightning conductor. Okay, they also use it in thunder arrest in buildings. Okay, thunder arrest in buildings where they make. So all those lightning where they come, we're supposed to destroy the building. That lightning, that thunder arrestor is going to do what? It's going to capture it. It's going to absorb this lightning. It absorbs it and it diverts it into the earth. Okay, that's into the ground. Anytime you hear ground, you understand an earth that they talk about. So that's the function of electric lightning arrestor. Or I already told you what electric lightning is. It's the spark brought about by the interaction of electric charge. Okay, the spark brought about by the interaction of electric charge. And I told you before here I told you how spark can be formed and how it leads to the loss of charge. This is Coulomb's law. And what did Coulomb state? Okay, Coulomb is a physicist that has a great contribution when it comes to electricity in physics. His law states that the electrostatic force between 2 point charges is directly proportional to the product of the charges and inversely proportional to the square root of the distance between them. This law is like the universal law of gravitation by Newton. Okay, but they are slightly different because this one we are talking about electricity. Okay, so the electrostatic force between 2 point charges is directly proportional to the product of the charges and inversely proportional to the square of the distance between them. It's given by this relation here. This K you have here is the constant, electricity constant, all right? Where F, which is F, the force, see I'm here, inside the law here, force between the charges. Since we are talking about two charges, 2 point charges, we are going to have Q1, which is charge 1, and Q2, which is charge 2. This Q, in your calculation question, is going to be represented with Coulomb, okay? It's going to be represented with what? Coulomb, all right? So Q1, Q2. So between the 2 points, is directly proportional to what? The product of the charges. That's why you have to do what? Times these two. You can see that force here is equal to when you times these two. Okay, you can see it. When you times these two now, force is equal to it. It's said directly proportional to the product when you times two of them. And it's inversely proportional. It's inversely proportional like this. Okay, when you say directly proportional, like this, the same direction. Okay, the same direction. But inversely, like this. So if this one dey high, this one will be low. If this one dey go left, this one will go right. But if you say directly proportional, if this one they go up, that two of them will go up together. Then they come down, they go down together. So that's it. So inversely proportional to what? The square of their distance apart. This arrow here is for radius, the distance of the charge. All right. Look at this. Anything where we say I use red, they right. Always they draw your attention. You go there. Look at that thing. Okay, because it's very, very important. That's why I put it in red to draw your attention to that thing. All right. So the direction of charge, attractive for unlike charges and repulsive for like charges, is the law. Under this Coulomb's law, that's where you have this like charge repair. That's like charge, no, they marry. But unlike charge, they marry, they attract. Unlike charge, that's when you have negative, positive, they attract. But when you have positive, positive that are like charge, they don't go marry. They go what? Repair. Okay, they repair. Okay, they don't want to get anything to do with each other. All right. So they use marriage. They remember that man fit marry woman because they are unlike. Okay, this one a man, this one a woman. But man no fit marry man because they are like. Okay, that's gay marriage. They are like. They agree to marry man, marry man. No. Woman no fit marry woman because they are like charges. They agree. No. And that's how it is in magnetism. Okay, like pole repel or like pole attract. So north and south pole will attract, but north pole will not attract. South pole will not attract. It will repel. So Jamb get the way they take day. You get some kind of question where they will give you where you go need to put this thing where you see for here, which is the constant of proportionality. See am here. It did the Coulomb's law, but we no put am in full. Waiting it dey equivalent to. So see am here now. Here now we put the constant of proportionality here. It can't be like say we complete the law. Okay. So this K where they here now stands for this thing where they here. So this thing. That is the what? The constant of proportionality. And for this full Coulomb formula, make we know the meaning of everything where they. I know say I don't fair tell you before, but make we look am for here. F is the electrostatic force, okay, between two charges, okay, usually in what? Newton. Now you will see. Q1 and Q2 now the what? The magnitude of the 2-point charge, okay? Usually what appear in what? Coulomb, okay? You see it in Coulomb, okay? That's the unit, all right? Then R is the distance between the charges, all right? So the unit is meter, that's in M, all right? The distance, all right? More like the radius. So E naught is permittivity of free space. What is permittivity of free space? Like, for example, in a vacuum, for example, an enclosed space is the amount of space required for current to be transmitted in a space, in an empty space. Okay? The amount of space required for electric currents to flow in an empty space. That's permittivity of free space. And the value is 8.85 times 10 to the power minus 12 Coulomb square per Newton meter square. And the value is 8.85 times 10 to the power minus 12 Coulomb square per Newton meter square. So most of the time that they give this thing, okay, they will give it or say take E naught or permittivity of free space equal to this, all right? So no distress yourself too much. They say you want the grammar. Then this one, which is the constant of proportionality, often written as K, where you see for here, so, and the K is equivalent, it has its own equivalent to 9 times 10 to the power 9 Newton meter square per C square, which is what? Coulomb square. So if you want to use this to solve, depending on what they ask you, make you find, and depending on the parameters where they give you. Then before you solve, the first thing we need to do now to quickly write out all the parameters where they give you and look at the options, which units the options they. Then another one will help you predict the formula to use or how to derive your own formula where you could find the answer. Not be all physics questions that they use one formula that gets the answer. Someday where we say you feel just derive formula from another formula, you use a form new formula, use and get the answer. It's very easy. All you need to do is to do subject of formula and get your answer. Because as this Coulomb law they so, they fit come now tell you say make you find the first point charge. Or they'll tell you say find the second point charge. Or they'll tell you say make you find the what? The distance. How you go take do one? Is it not subject of formula you will do? All this one are part of wetin Jamb wants make you know. Now see they syllabus, now so I dey give am. So this one now inside my notes, everything as it short like this. The wetin Jamb want for your syllabus, the objective. Now we can make all these notes. So make sure say everything dey inside. So if you need and send me DM, just go my profile. You see phone number underneath for that. Adam, make you send me DM. We are looking at capacitors. What is a capacitor? A capacitor is a device which store electric charge. That is a capacitor. Any device that stores electric charge is a capacitor. Some textbook will tell you a capacitor is a condenser that stores electric charge. Why they call them condenser? They call them condenser because it condenses this charge. It is through these stages of condensation that it stores its charge. That's why some textbook can tell you it's a condenser. Some will tell you it's a device. That's it. Now let's look at the types / the functions of capacitors. There are two types of capacitors. Okay, we have the parallel plate capacitor. That's the way they connect them. It all depends on how they connect the capacitor. What is the component of the capacitor? The types of capacitor and the functions by components. Okay, so parallel plate capacitor, the plates are connected parallelly. All right, so it stores energy. That is the function of parallel plate capacitor. And the second one we have here is electrolytic capacitors. Okay, electrolytic capacitors. And what is the function of electrolytic capacitor? It is what? It has a high capacitance. It has a what? High capacitance. And we are going to look at the capacitance of a capacitor, which means the electric charge that a capacitor can hold, the capacitance of the capacitor, the total electric charge that it can carry. So this electrolytic capacitor that has a high capacitance, it is used in circuit for smoothing / filtering of charges. Okay, so you use it in circuit to smoothing the charge and what? Filter the what? The charge. So anything smoothing and filtering of charge, just use this electrolytic capacitor. Anything to store energy, okay, where the storage of charge is needed, okay, you use parallel plate capacitor. So this electrolytic capacitor is used most of the time together with parallel plate capacitor, okay, to, you know, give a desired outcome of charge stored. All right, so it all depends on the outcome, what the person that is using this capacitor wants to achieve. That's what is important. All right, but just know their key uses and the type of what they are made of, or what they do, how they provide this value. Okay, like this one now, the value is smoothing and filtering of charge, okay, in the circuits. Okay, that's the function. And so what feature does it have that gives it this value of smoothing and filtering current? Is this high capacitance that it has. Okay, now let's look at both of them one after the other. So parallel plate capacitor, it consists of two plates separated by dielectric. Two plates separated by what? Dielectric. What is capacitance? Capacitance of a capacitor. Jamb said we should know the formula. Say they will pack questions come out from the calculation. So the capacitance of a capacitor, C, is equal to Q over V. You can use this one, this formula, or you can use this one, EA over D, where this E is permittivity, where A is for area, where D is for distance. So this one has both distance, area. So it all depends on the parameter you were given in the question. That's what is going to determine the formula that you are going to choose from here. And you can also merge the two formulas depending on the parameters you are given. If you see say the parameter where they give you almost everything there inside, both permittivity there, both area there, both distance there, you will have to bring the two formulas together, just like they put them for here now. You will bring them together, use and solve. Because, or if you be say waiting they give you now this formula mash am, you use this formula. You can also do subject of formula to derive formula to solve question, like I always say. For example, now this one, C is capacitance, Q is quantity of charge, but V is voltage. All right, so they can give you voltage and give you capacitance. They will tell you that what is the charge. What will you do? You make Q the charge, the subject of the formula, and get your answer. Very easy. Okay, you have to discern, you have to analyze, be analytical. Because that's why you have to read the book 72 hours to Jamb UTME. It gives you these analytical skills. Okay, so read that book 72 hours to Jamb UTME. You don't just rush into answering questions. No, you have to look at what you were given and look at what you have available. Before you decide on what to use for that question. Jamb also said we should also focus on the factors affecting capacitance of a capacitor. What are the factors that affect the capacitance or that determines the capacitance of a capacitor? So under the factors affecting the capacitance of a capacitor, the first we have here is increasing with A, which is as area increases, capacitance of the capacitor increases. That is directly proportional to area. So if area they increase, capacitance will increase. Okay, if area they reduce, capacitance will reduce. Okay, the second one is it also increases with dielectric. So if dielectric increases, capacitance will increase. If dielectric they reduce, capacitance will reduce. Take note to Jamb, they ask this question well. The third one is decreases with distance, which is D. So what it means is that the more you decrease the distance, the lower the capacitance. Okay, so it decreases with distance. So as distance they decrease, capacitance will decrease. So in essence, if you want to increase the capacitance of a capacitor, all you have to do, increase the area and increase the dielectric. If you want to decrease the capacitance of a capacitor, what do you have to do? Decrease the what? The distance. The capacitance of the capacitor will be decreased. If you decrease the distance, the capacitance of the capacitor will decrease following it. Now let's look at the calculation of capacitor where they turn I for inside exam hall. It's very easy, but they turn I because of resistance. All right. So capacitors can be connected in series or in parallel. Okay. For the series capacitor, there is a formula for it. For the parallel capacitor, there is a formula for it. Remember, in resistance, when you have resistance in series, that's when the resistance is connected horizontally like this, straight. It's connected straight, no different connection on it, just straight, one straight connection like this. You just plus everything to get your answer. Add 1 over R1 plus 1 over R2 plus 1, you get your answer. But if it's connected in parallel, that's connected parallelly, it has different connection, okay, as different ends, it has different connection. You use what? 1 over this one plus 1 over this one plus 1 over this one. That means you are going to apply some principle to solve it. It's not just to just add everything together. Okay, some people go to use the LCM way. Some people go use my own shortcut. You times and you plus, then you divide. Okay, it all depends on the style way you use. In capacitor, it is opposite of resistance. So use resistance as a guide. Since na resistance, you know and well. Use that one as guide. So when you see capacitor, you go say, capacitor na opposite of resistance. So for capacitor now, series that was supposed to be plus, You can see it. It's now the 1 over C1 plus 1 over C2 and so on and so forth. Parallel, that is supposed to be 1 over something in resistance. That's, you can see what you are now having here now. C1 plus C2, just plus and get your answer. So it's opposite in capacitor. Okay? Alright. So what is the formula for the energy stored by a capacitor? Is E, which is energy, is equal to half CV square. Where C is the capacitance, where V is what? The volt. And equal to, you can also use this other formula. Okay? Volt square. You can also use this other formula, half Q square over C. Q is charge. Okay? Over C. Q raised to the power of 2 over C. You know what C is, right? That's capacitance. So you can use any of the formulas here, depending on what you are given in your parameter. So if in your parameter, if you are giving volts, this one will be better to use. If in your parameters given, if you are given quantity of charge, which is in coulomb, this one and this one you will use. All right? To get your answer. As easy as that. Easy peasy. Now that we have understood capacitor, capacitance, energy stored by capacitor connected in series and in parallel, the types of capacitor and so on and so forth, let's now take some Jamb must repeat questions to test the knowledge we've acquired and measure our preparedness for Jamb UTME 2026. Jamb must repeat questions. Question 182. Capacitance of a parallel plate capacitor is given by what? A. C is equal to Q over V. B. C is equal to this small thing like EA over D. C. Both A and B. D. C is equal to V over Q. What's the answer? Drop the answer in the comment section. Question 183. You know book abi? Oh yeah na. To increase capacitance, you can what? A. Decrease area. B. Increase distance. C. Use dielectric. D. Decrease dielectric constants. What's the answer? Drop the answer in the comment section. Question 184. In series combination of capacitors, what's the formula? A. Blah 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 blah. B. Blah 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 blah. C. Blah blah blah. D. Blah blah. What's the answer? Just kukuma drop the answer in the comment section. Question 185. Energy stored in a capacitor is what? A. Half CV square. B. CV square. C. Half QV. D. QV. What's the answer? You know the answer, right? Drop the answer in the comment section. Question 186. Capacitors are used in A. Heating circuits. B. Smoothing voltage. C. Generating light. D. Measuring temperature. What's the answer? Drop the answer in the comment section.